In this video, we're going to talk about how to deal with equations with rational numbers in them. If you follow the principle of doing it the way we've taught you, you would subtract the 1 and then you'd have to deal with the 2/3. It's a really big pain. So what we're going to show you is how to get rid of the fractions altogether. What you're going to do is you are going to look for the least common denominator between your two denominators that you have. You have a 3 and you have a 4. So 3 and 4, the least common denominator, you got to multiply up. So to show you what that looks like, 3 times 2 is 6. 4 times 2 is 8. Those are not common. 3 times 3 is 9. 4 can't go into 9, but 4 times 3 is 12. So you can do 3 times 4, which is 12. So your least common denominator is this 12 right here. So what you're going to do is you're actually going to multiply the entire equation by 12. So what this is going to look like is a distributive property. 12 times 2/3 x, 12 times 1, and 12 times 5/3. So we have 12 times 2/3 x plus 12 times 1 equals 12 times 5/4. Now the reason I wrote this all out is so that we can have a 12 for each individual component. So put these all over 1 where you need it. 3 goes into 3 once, it goes into 12 4 times. So you now have 8x, and the reason why is because it was 4 over 1 times 2 over 1, which is 8, and then you just attach it to the x, plus 12 times 1 is 12. And then over here we have 4 goes into 4 once, it goes into 12 3 times, so that equals 15. So now you have a much more manageable two-step equation. So I'm going to now follow our rules. Subtract 12, bring down your 8x is equal to 3, and then you'll divide by 8 on both sides. So x is equal to 3/8. So that's much easier, even though it's still not the prettiest of answers, much easier than having to subtract, find common denominators, then divide, all that stuff. Alright, the next type of problem is dealing with decimals. Now there's two ways you can go about doing this. If you are comfortable with dealing with your decimals, you can in fact do your great divide and do minus 3/9 minus 3.9. Those cancel out. You have your 0.4x, which is equal to, you have to 17,4,188. And then you can divide by 0.4, divide by 0.4. So then your 0.4 is on the outside, 1.88 is on the inside. You cannot have decimals on the outside, so hop, hop, bring decimal up. You have 4 minus 16, 28, 7. So x is equal to 4.7. So this way isn't bad as long as you know what to do with your decimals. But I'm also going to show you one more shortcut trick. So coming back to the original problem, I'm going to show you one more way that you can do this, just kind of like the other one. What we want to do is get rid of the decimals altogether. So what you can do is you got to figure out which one has the most hops to get rid of it. So this one right here has 1 hop, 1 hop. Oh, but this one has 2 hops. So what that means is that we will have to multiply by 100 to undo it. Now, had all of them only had 1 hop, we would multiply by 10. If one of them had 3 hops, we'd multiply by 1,000. So it's just however many hops you have, that's how many zeros you'll attach to 1. So when we do that, we'll hop hop and we'll have 40x plus 390 because we're hopping twice, hop hop, and then it will be 578. And now you are completely rid of those decimals, and then you just treat it like a one-step or a two-step equation. Minus 390 minus 390. 40x is equal to, and again we'll have to borrow, so 17 and 4, so 188, divide by 40, divide by 40, and you have your 188 inside, 40 on the outside. Can't go into 1, can't go into 18, but it can go into 184 times. Minus 160, 280, create your decimal, bring it up, create a 0, bring it down, and 7. So again, your numbers are exactly the same. It is still 4.7. It's just a matter of, do you prefer to deal with the decimals and know your decimal rules, or do you prefer to get rid of your decimals and just deal with integers? So you get to choose.